All right. Hello, everybody, and welcome to the stream. I hope everybody is doing well tonight. We are, I guess, starting just about on time tonight, actually. I know we missed last night's stream due to some technical difficulties that I had locally, but thankfully, I think I've worked all those issues out, so we should be good to go to continue tonight. So we'll see. We might have a makeup stream tomorrow night. I'll try and announce that uh, sometime tomorrow if we're going to wind up doing that, but I'll let you guys know. But, anyways, thank you guys for being here. I appreciate it. And speaking of that, before we jump into what we're going to talk about tonight, I do want to just take a quick second and thank the supporters of the channel, starting with our first elite partner, who is Javier Olazaran. That is the highest tier of support over on Patreon. And then our partners listed here as well, I would like to thank. That is the second highest tier of subscription over on Patreon and YouTube memberships. They are Furkan Tokan and Gerbales Inc. I'd also like to thank all of the other supporters listed here. They are a combination of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for your support. It is greatly appreciated, and it helps me cover expenses incurred while running the channel, hosting fees, things like that. So thank you all very much. It is greatly appreciated. And speaking of appreciation, I appreciate each and every one of you viewers who are here, either catching the VOD after the fact, or whether you're here live with us, either on the YouTube side or the Twitch side. We do simulcast to both. I have both chats up. I keep an eye on those. So this is designed to be an interactive stream, so feel free to jump in and say hi, join the conversation. And if you have any questions, feel free to ask, and I'll answer them to the best of my ability. Okay, so in terms of what we're going to talk about tonight, it's actually going to be a little bit of a branch off of what we've been talking about, because I actually came to a realization while I was looking at some things offline. And, there are some things that we need to adjust and kind of move around in addition to some of the resource work that we're doing, because I kind of realized that some of the ways that we were doing things, again, were a little bit incorrect in terms of how things should be organized when it comes to specifically static meshes. But then I got to thinking about it a little bit further and decided that we need a little bit further reorganization of some things. And this is going to save us a lot of effort going forward when we add more complex types. So I think it's something that we should probably also address now. So, LaFoley, how's it going? Good to see you. Welcome. I hope you're doing well. Okay. So, the title of the stream was talking about resources, actors, which is something we haven't discussed yet, and actor components, or just, I think I just put components in there because actor component was too long. So, we're going to talk about that. But we're going to talk about what led me up to that, which was sort of the way that static meshes, or the way that currently meshes, work. So the way that meshes are currently organized in the system is that we have a mesh that is composed of a geometry, right? One or more geometries. A single mesh can have multiple geometries. And then each one of those geometries could have a pointer to a material, and that used to be here. I've since removed that, but the way that it worked was we basically had a pointer to a material for each geometry that we had, and this didn't make a whole lot of sense outside of geometries that were used in the world. So a geometry here is basically just supposed to be a representation of geometry only, right? So it's how many how many vertices we have, what the size of each of those vertices are, the vertices themselves, and then the offset into the vertex buffer that they were added into. And I could even argue that this maybe doesn't even belong here, right? But that's for another time. We also had a couple of things in here like our center point, our extents, used for bounding boxes, things like that, an IED and a generation. All of this stuff made sense, right? But then we also had a pointer to a material in here, which didn't always make sense, right? So geometries can be used for lots of things besides just rendering a static mesh, right? We could use them for UI controls, for example, which is one of the uses that we actually have. And UI doesn't use materials. We could use a geometry to maybe define like a volume in space, right? Maybe a blocking volume or a water volume or something like that. We could use it for, to define like a physics level geometry, right? Which again doesn't need a material. And so I got thinking about, well, how do some other engines sort of handle, grouping together a geometry and materials? And basically, the answer that I kind of came to upon thinking about it was, for the most part, they don't. The geometry knows nothing about a material, nor should it really. It should be a completely separate concept. And then I got thinking, okay, well, if a static mesh can have multiple geometries, but each one of those geometries technically could have a separate material, which is the case in our sponza, which is sort of what we've been using as one of our test identifiers to date. If we could have a separate material per geometry there, then we would also have to maintain an array of materials to go right along with those geometries, which also kind of doesn't make sense, right? Because when we break it down, we have a static mesh, right, is what we're kind of leaning more towards. A static mesh should really just have one set of geometry and a material, right? And so I got thinking about it, and I'm like, you know what? We really ought to just kind of stick to that and have a static mesh, like one static mesh has one geometry and one material. And if we want something more fancy than that, then maybe we split that off into something else. But when we import something like the Sponza, and I even tested this in like Unreal, for example, I tested this in editor packages as well, such as Blender. And the typical way that works is whenever you import like an OBJ that's got a whole bunch of objects like that with different materials and so forth, all of those things actually get imported as separate meshes or separate objects, which sometimes, depending on the way that's set up, can either be grouped or not grouped, and so forth. So what we're going to wind up doing here is we are actually going to change the way that static meshes work to have a one-to-one relationship with a geometry and a material, or specifically a material instance, which we've already talked about before. So we're going to change up the way that static meshes work in terms of that, in terms of the way that they're imported. And so that's one thing, right? But then much like how we were talking about materials, and maybe a material should have a material instance. Whenever you acquire a material, you should get a material instance out of that, right? So that you can have object level differences between them. We should also have something similar to that for geometries, right? And so that kind of is leading us to the next part of our discussion. Looks like I've got some notifications over here, though, so let me check on that really quickly and catch up with chat, and then we'll go from there. Apotham and Coffee Lava, thank you guys so much for the resubs. I really appreciate the support there. Thank you guys very much. You guys kicked off a hype train, actually, which is kind of cool. Champerado, thank you for the follow as well. Welcome. Let's see. Apotham, good to see you. Coffee Lava, good to see you as well. Okay, I think I'm caught up. Yes. Yeah, so thank you guys very much for the support. That means a lot. I really, really appreciate it. Thank you. Okay, so we have some work to do around static meshes. But then I got thinking, well, we really ought to think about doing something similar to what we did with materials, where whenever we acquire a material, we don't use the material resource directly. We get a material instance that has sort of localized information about it. It has a pointer to the material resource, but we don't actually return just that, right? And that allows us to, maintain the sort of reference counting that we need, and so forth. So I'm thinking that we actually should do something very similar with static meshes. And that was when I got kind of thinking about, well, maybe we have something like an actor, right, which is what gets its representation in the world. Um, and so anything that goes in the world, maybe we call that actor, right? And within those actors, we would have like what we call sort of actor components. And then each actor type would have its own system. And so I know what you're probably thinking. You're probably thinking ECS, right? But we're not talking Unity style ECS. So Unity style ECS is literally entity and component. And then it's a system that manages those, right? That is not what we're talking about. What we are actually talking about is it would be sort of like a entity component, and then each one of those has its own system, right? Which is different from saying there's a system that manages entities and components. Now, we are not going to be talking about entities. We're not using those. We're going to say actors. So we're going to have, we're effectively looking at an actor and an actor component system, right? And so this is not going to be like a OOP, inheritance-based type of thing. This is going to be, we are going to have several distinct types of actors that each have their own, several different types of actor components, right? That each have their own individual system. So you could think of this as a actor, if I can type it correctly, actor component system, right? And so this is more the software architecture pattern than it is talking about like an ECS like you might find in Unity, right? And I know it's a little bit confusing, but what I'm leaning more towards is this, because what this is going to allow us to do is give us something that's extensible, right? All we have to do is create a new actor component system anytime we want to add a new actor component type. And then actors would basically just own actor components. And then actors themselves would essentially replace what we have in the scene right now, which is nodes. And those would essentially be placed in the world and either have a transform or not. They don't necessarily have to have a transform. But an actor can have a transform, and an actor component can have a transform. And then it's up to each individual actor component system for that particular type to handle the logic. So all an actor component is just a structure. That's it. Like, it doesn't have weird function pointers or weird sort of inheritance type of things. It just is just data, right? It's just a structure with some data in it. An actor is much the same thing, although we may have some functions to manage those, but it's going to be extremely lightweight, right? And so each actor component system will have the functions that act on that actor component type. So yeah, I hope that makes a little bit of sense. When I first heard about ECS, I thought it was the best thing ever. Then I used one, and my mind changed super fast. Yes, I agree. Yeah, so I've been racking my brain about this for a while, and how I kind of wanted to approach it, and this is kind of what I landed on. We're gonna try it and see if it works, right? Maybe it will, maybe it won't, but we'll see. Arihiza, I love the Doritos chip emote. That's super funny. Are bindless textures a good feature to support, you think? I haven't come to a conclusion on that yet, because here's the thing. I would have to do it in such a way where I can do that using multiple backends, right? So I don't know how to do that off the top of my head in Metal yet, and I don't know how to do that in Direct 3D 12. So if I do wind up implementing bindless in a way that affects the front end, which it might, I probably would put that in place after I write at least one more rendering backend. I know a lot of people swear by that. I have not actually messed around with it enough to come to a conclusion on it. It's a good question, though. If I were writing a non-generic engine, or a very bespoke engine, I probably would have done that right off the bat. But what I have to keep in mind for this particular project is we have to support, multiple different types of games within reason. And so I have to be as flexible as possible, which is what I'm trying to think of with all this stuff that we're talking about too. So I would say bindless is good to support if there's another asterisk on that, right? Because not every GPU out there supports it. So there's that too. At least when you're talking about Vulkan. I can't speak for Metal or Direct 3D off the top of my head because I haven't done it there. But I know at least with Vulkan, support is somewhat limited. Especially when you're talking about mobile, right? So if that's a thing that you have to consider, think about that for sure. All right. So with this, and this was, this bit here was just me kind of brainstorming and thinking, right? So what I started kind of coming up with was this K-actor types file, where I kind of started just thinking about maybe the way that some of this stuff would fit together, just thinking about the actual structures. And so we might have, in fact, I'm going to close this other buffer so that you guys can see this pretty well. Yeah, looks good. All right. So the way that I'm kind of thinking about this is we have this K-actor, which for right now is essentially nothing but just a named sort of structure that sits in the world, right? And it can have an X form or not. And then we have a K-actor component, which again just has a name and a type as its sort of base, right? And so essentially there's a couple ways that we could do this. We could have one system that sort of operates on a switch case for all of the different logic, which is one way that we could do it. Or we could split them out into a whole bunch of different systems. Or we could have some combination of the two, right? So we might have, maybe we do set up a system that handles both static meshes and skeletal meshes, for example, and then switch on those types. And so this kind of setup would allow us to do both of those things, right? And maybe Skybox has its own system, and height map terrains have its own. I spelled that wrong, didn't I? Yes, I did. There we go. So the way that I'm thinking about this is, we have all these different component types. The default would be unknown, which would keep us from having like a default of, zeroed out memory would basically be invalid in this case. Maybe we just call this empty and it doesn't do anything. Although I don't really want to create an empty component type. That doesn't really make any sense. But yeah, basically what I'm thinking is we have these K-actor components, right? And then a specific one would look something like this. So we have a K-actor component static mesh, which would contain the base, right? Which gives us this name and type, right? But then it also gives us a geometry and a material instance. And this is essentially the way we would set these up. So like a Skybox might give us, the cube map resource or something like that. And I think does a Skybox actually have geometry? I don't remember if it has geometry of its own. I think I just hard-coded it in the shader. If not, I probably should do that. But yeah, that's kind of what I was thinking. And then maybe we have something like a function that looks something like this, where we have like a K-actor component get, where we can pass a pointer to an actor and say, hey, give me an actor of or a component of this type with this name, right? And we could use that typing information to sort of filter, or maybe we don't include that at all and we just go by name. The advantage here being that you could have technically components that maybe share a name but differ on type or something. And then, maybe we also have the ability to add a component, which following a struct pattern like this would allow everything to be just castable to a single K-actor component, which would be here. And then the underlying system would know how to add that. So let's see. Can you have multiple components of the same type? Yes. Um, yeah, because the way that I was thinking about it was like I could definitely see, you setting up an actor and wanting to have multiple skeletal meshes or multiple static meshes, for example, um, or multiple lights potentially, right? So yeah, it that's one reason we're doing it this way. Let's see. It's crazy how foreign game programming can look sound sometimes, even when you program professionally every day. Yeah, it is very very different from anything else out there for sure. Let's see. See, I'm glad you're here, Coffee Lava, because I know ECS is your favorite thing. But we're not doing ECS in the way that everybody thinks we're doing ECS, right? We're not doing an entity component system. We're doing entity component systems, right? There is a distinction there where each type is managed by its own system. And so it's not like the super OOP model that like Unity uses, right? It's all of our components don't have they don't have functions of their own. They don't have function pointers, any of that crap, right? All a K actor component is literally just a structure, and that's it. All a actor is literally just a structure, and then any functions go through the system, right? So like this will probably wind up being like a actor system component get or something like that, right? I haven't completely thought it out yet, but that's kind of what I'm thinking towards that. And I think this will lend itself really nicely to being able to split things up like this, where our mesh will have the geometry and it'll also have a material instance, and we don't have to think about that any further, right? It's kind of like Unreal, but the thing is Unreal uses inheritance a lot, right? We have, I guess, what you could call one level of inheritance, right? Which is just this. But we're not going to have like multiple levels of this stuff. I'm not doing that. It's going to be, just single layer, right? So we're not going to be doing function pointers all over the place and stuff like what Unreal does. And that's going to be the difference, right? We're not doing OOP here. We're just doing, our components are nothing but data. Yeah, Unreal is all class based, exactly. But the core idea differs from ECS in that an actor is more than an ID. For now, it is, yeah. Because an actor, has a name, for example, right? So we should be able to reach into a scene and get an actor by name, for example. Which you could argue a name should be like, or could be a component of its own, and maybe we switch to that, right? We could argue also that the X form could be a component as well. So, maybe this becomes an ID at some point, but we're not there yet. How is memory laid out for the components? So, memory layout for the components, I'm thinking, is going to either be one of two things, and this is kind of where I haven't really made a decision yet, because if I do it this way, and everything is kind of in a struct, right? Then it's going to be a array of structures, which isn't great, right? And I'm thinking since we have since we actually have the individual systems for these component types, we might just go with a structure of arrays, right? Instead of doing it this way. And then maybe the component itself just becomes an ID. And so we might wind up doing something like, for example, Kactor components static mesh. Maybe I should say static mesh components, right? So like type def struct that, right? And then we would lay out the memory. We would have geometry, some number, whatever. And then we'd say geometries, right? And then we'd have, K resource material instance, materials, Obviously, I'm not going to hard code the length of the array, right? But this is just to kind of give you an idea of what I'm thinking. So if we go with the structure of arrays, it would be laid out like this, which would give nice data locality to us looping through these things. But generally, it's going to depend on the actual component itself. Some components, this is going to make more sense. Some components, this is going to make more sense. And I think the components where this makes more sense is where you need to utilize both all the time. And for the static mesh component, I think probably this is going to be the way that we're going to need to go, because whenever we're talking about rendering or gathering the render data for a static mesh, we are going to need both the geometry and the material, right? So it really depends on what we're doing. Whereas, some other type of component may benefit from the data locality of doing it this way. And so the other thing that I was thinking was, rather than have a structure type like this, maybe we do away with all of this stuff, right? And we just maintain some sort of ID and or type that goes along with it. Let's see. Inheritance on Unreal is huge. I get mesmerized trying to figure out what stuff does, but there's so many functions that I can't. Yeah, and that's exactly what I want to avoid. Transforms could potentially be properties of components. They could be offset from the actor root, or you're going to have scene-like tree where actors' components can have children. So we already do have that via something else. We actually have... So the way that our scene currently works is our scene actually right now contains lists of... In fact, I'll just show you real quick. So our scene itself has these lists of attachments, right? So we have like these array of directional lights, array of point lights, array of meshes, right? Array of terrains, etc., right? And so I'm thinking that the scene would essentially replace this with the actors, right? And then later on down here, we actually have a hierarchy graph that stores essentially pointers to all of these different nodes that contain these different individual attachments, right? Which is what they're currently known as. So we have this hierarchy graph, which maintains that hierarchy for us. It maintains all of our scene hierarchy, which we can then use to figure out what our transform hierarchy is when we're getting all of that information. So the nodes themselves don't directly contain that information, and I'm kind of leaning towards keeping that with actors, right? Where actors don't have children actors. They are just a flat array of actors, and then based on maybe handle information or something like that, we feed that into a hierarchy graph and manage it that way. Did you consider a union for the component types? I did consider that, but there's going to be such a size disparity that wouldn't really work, and that's not going to be extensible. So I'd imagine it would be tricky mixing the two. So that's the thing, is if we design our systems correctly, it won't be tricky at all, because if we need to, say, grab properties of a particular component, right, we probably wouldn't be referencing the struct directly anyways, right? We would probably just say, hey, static mesh component system, give me the geometry for, um, the static mesh ID of 42 or whatever, right? And it would just return a pointer to this, right? And so you do that for the geometry, you do that for the material. Maybe we have, in that case, a function that returns both. And that would be how we handle that, right? So again, it could vary by system. And anything that would be having to interact with these components in such a way like that would know what functions to actually call. So I don't think it would be tricky at all. The way that this is represented basically becomes internal at that point. Champerado, thank you so much for the tier 1 sub. I appreciate that. Thank you very much for the support. Cave Edge, thank you for the follow as well. And Malicious Wyvern, thank you for the follow as well. Appreciate that. All right. Let's see. It's almost a bit... I don't know what that means. I have to Google that. I haven't heard that before. Let me see. Let's see. What does that mean? Tout le monde? The whole world, everyone, everybody? I think I see what you're saying there. I guess so, yeah. Let's see. Okay. Did I catch up on chat? I think I did. Bunny Slayer, how's it going? First time chatter, welcome. All right, let me catch up on the YouTube side here. Singy, how's it going? Good to see you, welcome. Would it be better to make a K-actor component type a bit mask so that multiple components can be assigned into the single value? Let's see. So when would I ever have to mix those types? I guess is what I would need to know. And we may not, I mean, if I do this right, we may not even need the type actually. Array of structures versus structure of arrays can't be determined to be good or not until the use cases become well defined. Exactly. Which is why ECS often use archetypes. Yeah. So, and that's one of the reasons I'm saying it really should be up to the system how it lays out its own memory. And I think that's a good rule for us to follow, is it doesn't have to be a certain way. It should be up to the system how to lay out its own memory, because it knows how its data is going to be accessed. And I think that makes sense. How's the hierarchy graph laid out? So the hierarchy graph right now, essentially, it's this whole... it's basically just a structure, right, that contains a bunch of node handles, a bunch of parent indices for those node handles, so these two arrays line up, and then a bunch of transforms as well, transform handles, right? And so a combination of those is used to figure out like how we get a full world transform off of something that's nested. And essentially what we do is we can add like a root node, we can add a child node to a particular node handle, and it basically just updates these lists as we go, and then we can just query these lists as we go, and they're just flat arrays. So it's super simple. And then what we can do is we can actually, let's see, these right here, so world rotation and world position, are actually baked right into the hierarchy graph. So this is aware of how to get those X forms for each one of those nodes, and so forth. So the graph itself doesn't actually technically know anything about the scene nodes. It's kind of its own thing. And when you add something to the hierarchy graph, you get a handle back. So this purely just deals with handles. It doesn't actually deal with structures or anything. So it's completely separated in that manner. It only deals with handles. Negative pointer, how's it going? It's going pretty well for me. Thanks for asking. Appreciate that. Let's see. I can't begin to understand how big your brain is. I don't know. It feels kind of small sometimes. You could cosplay Moses. That's a new one. I've gotten Odin a couple of times because of my beard. He's already doing more witchcraft. One thing I never understood, does a node contain just one mesh, like an OBJ file has multiple meshes, and then one mesh equals one node? So that's one thing that we're working on adjusting, right? So the way that it works right now, if I open up a scene file, so if we look at this scene file, this kind of gives us an idea of the way that these are structured, right? So we have a node array here within the scene file, and then this essentially here is a node, right? And then each of these nodes have an attachment. So an attachment can be like a skybox, it could be a directional light. So in this case, it's the skybox and the sun. It could be the sponza, right? Which is this node down here has a sponza. It has or it's called sponza, I should say. It has an X form of its own, and then it has a single attachment, right? Which in this case is a static mesh. We could have multiple static meshes here if we wanted to, but we don't have to. We could have no attachments if we wanted to. We could just use it as sort of a container if we wanted to do that. And then it can have children, which in turn are also nodes. And then those nodes can have X forms and attachments, right? So if we wanted to, we could do this, and that's completely valid as well, right? We could absolutely do that as well and have more than one static mesh in there, and that's totally valid. And we want to maintain that. The thing that we're going to have to figure out is, when we're doing the static mesh thing, the way that this works is going to be changing a little bit, because the resource name here, sponza, is actually right now imported as a single mesh that has a bunch of subgeometries, and we're not going to be doing that anymore. We are going to have one mesh is one geometry with a material. And so we're going to have to regenerate that. We're going to have to change our code to handle that. But it's also going to make things a lot more flexible and simplify some of the code that we do have when it comes to rendering and figuring out meshes. I hope that makes sense. Let's see. May I ask what resources you recommend for low-level programming and system architecture? So for this kind of stuff, one of the books I always recommend is Game Engine Architecture, for sure, by Jason Gregory. This is a really good book in terms of like breaking down what the individual systems are. I don't follow that to a T. I've branched off from that, but I have different requirements than what he does in there. But that gives you a very good primer on some design decisions and stuff like that. Let's see. Does the object have information about where the attachments go, or is that what you decide? Wait. Does the OBJ have information about where attachments go, or is it you that decides where or who gets an attachment? Yeah, so it's ultimately this file what decides that gets the attachment, right? So we create a node, and then we add an attachment to that node, and that's ultimately what determines where it gets placed. So this X form has position, rotation, which is a quaternion, and then scale, right? So this is ultimately what determines where it goes. And so probably what we would wind up here in this case, if we were to go and load the sponza or import it, is we might have some sort of grouping mechanism when we import those things. Let's see. I know Jason Gregory's Game Engine Architecture has been mentioned here before. I started studying it a few weeks ago, and I was wondering if anyone has an opinion on what good point when a good point to start making a super simple engine to cement some of its concepts is it better to do a full read through first, or is there a point partway through the book where it makes sense to start a little toy engine? So, what I would do is whenever you get the itch to sort of start one, start messing around with one, right? But I say that with an asterisk because I say that with the exception that you're going to want to basically redo it, right? Because as you read this book, and you're going to want to read that book more than once to catch everything, you're going to get so far and then you're going to go, oh, I see where I went wrong here. Throw it out and restart, right? And that's okay. The more times you do it, the more you learn from it. So, feel free to jump in and start writing it, but just don't get too attached to it because you're probably going to throw it out. And that's okay. It's a good learning experience, right? The more code you write, the better you'll get at it. So I would say, start whenever you think you're ready. Start working on something. Get as far as you can with it. Keep reading the book as you go, and then at some point you'll be like, oh, okay, I don't really like this design. It didn't work for this reason. Restart, right? Let's see. I hope that all makes sense. Brings up a question that I wanted your opinion on. Okay, I will wait for the question. Let's see. Can that be extended or repurposed for inverse kinematics? Are you still talking about the hierarchy graph? Theoretically, you could have multiple hierarchy graphs actually, because it's not actually connected to any sort of structure, right? So as long as if you have something that can hold a handle, right, which is really just a number, and you have something that can take transforms, right, you can create as many hierarchy graphs as you need, right? So you could have a local hierarchy graph for like a skeletal mesh if you wanted to do it that way, and maybe that's the way we'll do it. Where each bone would sort of have its own handle identifier, and those bones are sort of the nodes in the graph, right? That have a hierarchy. In fact, that's probably the way we're going to set it up when we get ready to do skeletal meshes. So yeah, I don't see why not. I made it to be as open-ended as possible so that you could use it with anything. It's not just for scenes, right? Thank you for the follow. I appreciate that. All right, let me see. I'm pushing a friend through OpenGL via Learn OpenGL, of course, and I think they should go all the way through advanced lighting before making a project. But some people say just do the getting started section. I also told them to make at least a deferred render before making a toy engine. Would you say I'm right or wrong on either of these? That's not the way I would approach it, and here's why. Learning OpenGL and graphics programming is a massive topic, right? And it's not something that you can just kind of like read through a whole thing and store it all up here in your noggin and expect to remember all that stuff at the end and then be able to go build an engine. At least that's not the way I learn, right? So it varies per person, right? I suppose if somebody has photographic memory, maybe they could do that. I know in my case, when I'm learning something new, I have to get in and write some code as I'm sort of stepping through that whole thing. That's the way I learned Vulkan. That's the way I learned OpenGL. That's the way I learned old Direct 3D back in the day. Is I would just have to build parts of it to gain an understanding around something. And generally it would be something that I knew was going to be throwaway code, and that's fine. It depends on the person, right? Not everybody learns the same way. Somebody might learn better from having the whole picture, and maybe they can store everything up here. That ain't me, that's for sure. So yeah, I prefer the go back and forth method with that. In fact, yeah, Dandy McGee actually said pretty much what I said. Yeah, it's not going to stick in your memory at all. Yeah. And if it can, then my hat's off to you, because I know my memory isn't that good. Just ask my wife. I forget crap all the time. Cool. Made a lot of sense. All right. Awesome. Perfectly fair. I think it's hard for me to remember what it was like being a complete beginner with 3D graphics. Yeah, and that's the thing I always try to keep in mind too. Is it's hard to get rid of that context in your mind and think, what is somebody that's just learning this? What do they know, and how far do they have to go? Because I guarantee if you were to pull up the first OpenGL renderer you ever wrote, you'd be like, oh God, what is this? Non-codes, how's it going? Good to see you. And then I learn the code and then forget it 6 months later, and I get confused when I look at it again. That's what comments are for. Yeah, learn OpenGL is a good resource for sure. For sure. Write long comments also when doing the prototypes to explain your thought process and things you learned, and that aren't obvious. Yeah, so this is another thing that I usually will do, and you guys will see me even do that here sometimes, where like I'm even kind of doing it up here a little bit, like just kind of spelling out in comments what the way that I think I want it to work. And sometimes I'll like write pseudocode in comments, or I'll just kind of section it out in comments, and then I'll go back and fill in the code. Working on my linear algebra course and Khan Academy. That's a great resource to use, by the way, for that. Very nice. I probably should brush up one of these days. I feel like linear algebra is one of those things I constantly have to brush up on, because I don't write the functions like every day, right? So when I have to debug those, I'm like, oh crap, how's this supposed to work again? Even though I've been using it for years. Let's see. Do you work on game engines, graphics on your job as well? Not anymore, but I did for 5 years. A couple years ago. Yeah. And then I also did some contract work before that for a number of years. But yeah, I moved on from that because I got tired of working 70-hour weeks. So yeah, I don't do it anymore. I save it specifically for this now. All right. I should probably get back to coding. All right. Let's see. Where were we? Hierarchy graph. Oh, I think I can actually kill this buffer. All right. So, maybe what we wind up with is really not even maybe not even this, right? We might also have maybe we use another handle. I guess we don't really need a handle for an actor. We just need like a unique ID. Which kname kind of is one, but kind of not. So let's actually go with I'm going to go with a U64 ID for now. And the reason that we're going to have this is we're going to be able to associate a component with an actor that way, right? We're basically going to say the actor with this ID is the one that owns this component, right? And that'll allow us to do relatively quicker queries, I'm going to say. I'm going to have to think about how I want to actually do that, right? So maybe our kActor component get, instead of this, taking an actor pointer, is really just going to be, a U64 actor ID, right? And then that, in turn, is just a quick numeric lookup internally. And actually, do we even want... I suppose we could have this reach out to a individual system, right? So we know what system to reach out to. We could pass the system the actor ID and then the name once we know that, right? So we might have, maybe we'll have these individual systems all register with an actor system purely for component lookups, right? Although, you know what? Let's not deal with actor component pointers at all. Let's actually try to avoid that. let's actually try to work with it this way, right? So like if we're prototyping this, let's say for example, we have we'll do B8 kactor component static mesh. Do I want to say system? I'll put system here for clarity, right? And then what we'll do is we'll say get geometry. If I can type. Material, right? And so we might have a an actor ID, right? So U64 actor ID. We would also do kname, component name, right? Which is really, again, remember that's just a integer lookup under the hood. And then it would also just have pointers to hold geometry, right? So out geometry, and then k resource material instance out material, right? Something like this. We might need to abridge that a little bit, but essentially, like if we needed to say, give me the geometry and the material for this particular component that's attached to this actor, all of our systems would essentially look like this. And then when it comes to memory, it doesn't matter if we lay it out like this or like this, because that becomes completely internal to the system itself. And at that point, if we needed to change the layout, it becomes an internal operation, and the rest of the system doesn't care, because the interface for that becomes the same. Yeah, it's a long signature though. I'm not gonna lie. I have to think about that, right? So we may have to abbreviate some of that, right? That's super long. Unfortunately, that's one of the downfalls of C, right? It's also kind of a downfall of not using OOP, right? Let's see. What would you say the minimum requirements for getting an internship junior position are in that field? Learning a bit of Vulkan, but I don't know what level of knowledge would be considered enough for a job. So that, unfortunately, I have to answer with it depends. It depends on where you're applying. The reason I say that is because some studios use engines like Unreal. Other studios use their own bespoke engines, which would require you to get down to the Vulkan level or the OpenGL level. Some studios aren't going to require that, right? So it highly depends on what role you want to do. Like, do you want to do game programming or do you want to do engine programming? And then what kind of engine programming? Do you want to be able to jump into something that's a proprietary code base, like something like Bungie uses, right? Or do you want to use Unreal? So the skill sets for that are wildly different. And so, yeah, it kind of depends on where you want to go. Let's see. Kactor comp SM get geom mat, but I'm okay with that. Those sorts of abbreviations. Yeah, I've tried to avoid abbreviations, but like this is rubbish. I have to agree. So like maybe it's obvious that it's a component system, right? So maybe it's just kactor static mesh system, or maybe we just eliminate system, right? Because we know it's a system. Because more than likely, we're also going to have to pass, some sort of system block of memory there anyway, right? Or I guess we'd call that state, right? Because that's kind of the pattern that we follow elsewhere, right? So we already kind of have that. Just put each argument on a new line. Yeah, I mean, there's that, obviously, right? But, like, this is kind of still long, but I think I can live with that for now. So, you know, yeah. I mean, we could definitely do this. It doesn't really matter because you don't really look at the header file all that much. I'm not really worried necessarily about the formatting of it. It's mostly just the length, right? Oops. Right. Yeah, it's more the name, exactly. Yeah. You know, because all we're really worried about is the name. The formatting stuff here doesn't really matter as much until we're done figuring out the rest of the code. I'm actually going to undo that for now. I guess it's still kind of verbose, but I think I'm okay enough with it for now. Right, it's just one example, right? And then maybe we also have you know, bespoke examples of this too, where maybe we just do one for the geometry and one for the material, right? Actually, I should probably do that instead, and then do, you know, material, right? So we have one to get geometry, one to get material, and then one that gets both. And this is the kind of flexibility that we'd have by splitting out these things. And probably what I would do is I would keep the actual state structure like internal. So I'd probably just do struct kactor component static mesh system state. That's really long too. I guess, right? And then this would just be kactor static mesh, kactor static mesh system state, right? Struct. Oops. Right. So at least it's typed, sort of. Returns a byte. So no, this is Boolean, actually. Yeah, B8 is just a Boolean. KCTR STT. Yeah, all right. I'm just gonna paste this into the window. I don't think I could bring myself to abbreviate it quite this much. That might be a bit much. Yeah, that might be a bit much. That's a little bit too old school style, I think. And the thing is like I've avoided abbreviating things elsewhere in the code base, so I kind of don't want to do it here because it's not. Yeah, old school naming, C naming conventions are gross. Yeah. Bools for errors, I get it. Yep. Yeah, so like any of these would return false if it were not able to do the thing. And then we could just, you know, check true or false instead of checking this value to see, you know, sanity checking this value everywhere we get it to see if it's true. You know, if it's truly valid. The Doom source code is disgusting, name-wise. Yeah, I looked at that a number of years ago, and it was something. So used to multiple returns, I forgot about out. Yeah, so I don't use multiple returns, obviously, because C doesn't have that. So yeah, this is the pattern that I follow for that, right? So I always put my output at the end, And then I use Boolean to determine success or false or failure. Unless I'm returning a pointer to something, obviously then I could just return null pointer. But in this case, we're not doing that. Name the function A and write a 5-line comment explaining what it does. That's ultimate old school right there. And I've worked on code bases where people have done that. It's gross. I prefer the strategy of returning a default geometry that just works, i.e. has 0 vertices and draws nothing or whatever. Then you never have to check for errors and can just log missing resources when they happen, but the game still runs. So that is what I'm leaning towards, right, for most things. Mostly what I would be checking for in this case would be so that I could log it wherever the request came from, so it was easily traceable. But I wouldn't like crash the engine if this failed, right? I would merely just put something in the console that says, "Hey, this thing failed to load," or failed to retrieve the geometry or material, or that actor ID is not valid, or something like that. Be sure to use HTML in the comment. Gross. Imagine having one function per line with no return, just out arguments, and it reads like a book. That would be interesting. Oof. Oof. Do I spy Jason Gregory's book behind you? Yes, you do, actually. It's right there. You are correct. I was just talking about it earlier on stream. Let's see. Max, how are you doing, by the way? Hope you're doing well. Let's see. I would just log inside of get geometry, then it's in a single place. Yes, but if I wanted to log it elsewhere, I could as well. So to your point, like for this single one, I could just do this, right? I could do that and not bother with the out. But it's a little bit inconsistent when I use this. So, I could return false here and then, return like a default material instance, which I probably would wind up doing anyway. And same goes for geometry, right? I'd probably just return like a default geometry, like a cube or something. Piano time. Nice. All right. So this is what I'm kind of leaning towards. And then each system would kind of essentially look like this, right? CM Griffing raided with a party of 70 viewers. Thank you so much for the raid. How are you doing tonight, Chris? Good to see you. Food being delivered, nice. If you guys aren't following Chris, you should definitely do it. He is a awesome developer here on Twitch. I'm just failing at typing the shout out. There we go. If you guys aren't following Chris, you definitely should be. He's a super cool dude. He's always developing really interesting things. The most interesting thing that I have seen that I really like is his feature flag software, which is pretty sweet. So I would have a look at that. But yeah, thank you so much for the raid. And welcome, raiders. Let me just get my spiel here out of the way so you guys know what the heck we're doing here. Thank you guys for the follows. I appreciate that. All right, so welcome, raiders. What we are working on is we are writing a game engine from scratch in C using Vulkan as our initial rendering backend. I say initial rendering backend because we do have plans to support Metal and Direct3D as well. It's completely free and open source. We'll come back to that in a second. It's cross-platform, so it runs on Windows, Linux, and Mac OS, with other platforms planned for the future. So what this project is all about is I'm basically building a game engine from scratch, showing all the steps that go into that, And I'm kind of doing this as an educational resource, as a way to build a game engine. It's not the only way to build a game engine. It's just a way to do it. Sometimes it's not even the right way. Sometimes we deliberately do things the wrong way to see why things don't work, right? And so this is an educational series, but it's also like highly experimental. We try different things, and we go through different design discussions. We're in the middle of one right now, in fact. But I'm basically trying to kind of create the resource that I always wished that I had to follow along with when I was learning how to do this stuff. So it started off as a YouTube tutorial series. We changed formats a few times. We landed on the live streaming format, and we stream on YouTube and Twitch. So as I mentioned, I should probably drop this link for you guys real quick in chat. So as I mentioned, we are completely open source, so we are on GitHub. And if we open that, we can see here that we are Apache 2.0 license, which means you are free to use this for either independent, personal, or commercial use. However you see fit, does not matter. The only thing that I ask is that you, if you do use it, that you say you used it, and that's literally it. It'll always be 100% free. I don't believe in paywalling stuff, right? If you want to support me, cool. If not, that's okay too. But I don't believe in paywalling that stuff. So there will never be any sort of licensing fees or royalties of any kind ever. It'll be 100% free always. So just to kind of go through what we have so far, we've got a basic PBR pipeline set up. We're still missing some things. These screenshots are a little bit old at this point, and I need to update them. But we have a physically based rendering pipeline with cascading shadow maps, the ability to manipulate objects in the world. So we're kind of building an editor as we go. We have the ability to render text. We have a UI system we're building from scratch with the ability to handle UTF-8 text, things of that nature. And then there's, the entire source code is here. So we are currently in the middle of a pretty large refactor. We're refactoring the way that all of our resources and assets are handled, and jobifying things, multi-threading things, and we're in the middle of a discussion about actors and components and how some of those systems are going to look. So let me catch up on chat. Thank you guys so much for all the follows, by the way. I really appreciate it. All right. So, have you done a video where you go through all your math functions in algebra? Most of them, yeah. It was early on in the series. Yeah, Trashcan says it's around episode 24 on YouTube. That sounds about right. Yeah. We've since added to it, but anywhere where we added to it, we also explain that in video. So, I don't believe we've added much of anything at all in terms of the math stuff without actually explaining it. Payday 2 and Borderlands 2, some of the best games that don't support UTF-8. Yeah, I wanted support for that right out the gate, so we do support that. Yep. Thank you for the all the follows. I really appreciate that. Let's see, stretch. I can do that. Could use one anyways. Ooh, my elbow popped. Nice. Cool. So I hope all that makes sense to all of you raiders. So thanks again, Chris, for the raid. I really appreciate that. And I hope you guys enjoy what we're doing here. So unfortunately, I can't run the engine at the moment because we're in the middle of a fairly refactor. It doesn't build or run at the moment. But these screenshots kind of give you a basic idea of at least a little bit what it looks like. And then actually we recently put some water in, which if I guess I could pull up our, does the BRB screen have it? I forget. No. I think the ad screen has it though. So this is a screen I use whenever ads come up on Twitch. But you can see the water effect that we added there. There's just a screenshot I took of it. So we also recently added that in as well. All right. Assume all of this low engine low-level engine stuff is learned from the book and experience and looking at other people's codes. None of my engines go into this much detail. Yeah, so this is a combination of looking at other engines, having worked on other engines, having written engines myself, both personally and professionally, as well as lots of research, reading books, stuff over the years. Yeah, it's kind of a combination of all that stuff. Um, so yeah, I hope all of that makes sense. I like looking at Godot for implementation inspirations if I don't know where to go. UE5's source is a mess, IMO. Yeah, they do a lot of heavy OOP in there. And so we're trying to avoid that like the plague here. There are going to be some places where we do it, but it's, as a rule, it's the exception, I should say. All right. So if we were to talk about I guess just to kind of bring this back into where we were before. So we have actors, which is just a thing that sort of exists in the world that has a name, a unique ID, and a transform potentially, which that may wind up actually changing too. And we're refactoring the way that our scenes currently work to use this stuff instead. So we have an actor, and then we have something called an actor component. And this struct is here purely just for reference purposes to kind of describe like what a K actor component is, right? So an actor is something that exists in the world, has a scale, position, rotation in the world, but then from there you can add components to that. So a component itself, at the most basic level, has a name and has a component type, right? So these are some of the component types that we have, like a static mesh, which is just a mesh that doesn't move. That's something like our Sponza object here, right? Or our car, the tree, whatever, That's a static mesh, right? We have the skybox, which I actually don't have a screenshot of. That's just the sort of sky that's in the background. Skeletal mesh is like a animated, like a character mesh that has bones and stuff like that. Height map, terrain, all these different component types, right? And so we're kind of just like talking about the way that these are represented in memory and the way that they're represented as a state. So each one of these component types will have its own individual system that is responsible for not only managing all the memory for all components of that type, but also handling all the functionality of those components. So a component is really nothing but a chunk of memory with just some properties on it. So a static mesh contains a geometry and a material, which defines how its surface looks, right? So the geometry is basically just going to be a collection of vertices and indices that define like a triangular mesh, how it looks in 3D. And then we have a material which defines various surface properties like wood, fabric, metal, whatever, what have you. And so this is kind of the traditional way that you would set something like that up. Whereas our systems will probably look more something like this internally, where we have an array of geometries and an array of materials that link back to a actor of a particular ID. So that when we reach out to the system and we say, hey, static mesh system, give me the geometry for this actor ID that is named this, right? And then put it in this location. And that's basically the way that these particular functions will work. And then they return a Boolean, true or false, as to whether or not that was successful. So if we pass an invalid ID here for the actor, or an actor that doesn't actually have a component with the system registered, then it would return false. Otherwise, it would return true. Chris, welcome back. We don't generally do OOP around these parts. Yeah, exactly. It has its uses, right? But for something like this, you generally don't want to do that for data locality reasons. Is there an example on how to use the engine? Not yet, only because, you could look at testbed. So this is what our project structure looks like. Essentially what we have is everything with Kohi dot here is sort of a shared library that contains a portion of the engine, right? So we have Kohi core, which contains like our um, things like our container classes, right? Like I say classes loosely, like our dynamic array, our free list, our hash table, queue, stuff like that, right? And then we have some debug stuff in there, like assertions, our math libraries in here, our memory management, including all of our allocators, are in here. Our individual parsers that we've written are in here. All of our platform code is in here. So the Mac OS, Linux, Windows platform code is there. Our serializers / deserializers live in here. Our string library lives in here. Threading, all that kind of stuff. You know, the super low level kind of stuff. So we have the core there. We have the runtime here, which is what the application using the engine actually is going to be referencing the most. So this contains things like the core game loop, our individual systems, our renderer front end. And I say renderer front end because a renderer has a front end and a back end. So our renderer front end is the renderer API agnostic stuff. So when I say renderer API, I mean like Vulkan, OpenGL, Direct3D, things of that nature. So the renderer front end is the stuff that's agnostic of all that stuff. It doesn't care about what the renderer back end is, right, which is Vulkan or what have you. It's all the stuff the rest of the engine understands. And then it also has an audio front end for similar reasons. It has stuff to deal with assets, resources, handling plugins, some basic core things like our console, our event system, input handling, stuff like that. And then from there, we have plugins. So this engine is utilizing a plugin architecture. So even the renderer itself, the renderer backend, is a plugin. The audio backend is a plugin. The UI system is a plugin, which means it's optional. You don't have to use it. It's optional. And then we also have a utils, which is kind of like a debug plugin that is only used in debug builds. So you can actually swap out what plugins you use based on what build you're making, things of that nature. So we have that, and then what drives all of this is we have the testbed application, right? So we have this testbed kapp and testbed klib. And the reason I put k in front of them is because if you do .app, macOS doesn't like that so much. Same with .lib. And so even if it's in a folder name, it just doesn't like it. So the kapp is basically a super, super lightweight executable, right? So all the rest of these up here, these are all libraries. This guy is an executable. And all it contains is the entry point to the application, which is some basic setup stuff, and that's literally it. The klib is where all of the application code or your game code is going to live. So we have a bunch of stuff in here, like our game commands, keybinds, game-specific code, and stuff like that. So this is the actual driver of it. And the reason these two are separated is because we can actually start up the executable and then make changes to the library and recompile that while it's running. And the executable can actually hot reload the game code library, right? So that's why we have those two set up. So an example of how to use the engine would be right here. We don't have it documented yet because it's still in fairly early development, and we're not going to bother documenting that stuff until we have it stable. So I hope that answers your question. I know that's a bit of a long-winded answer, but it kind of gives an overview of the project as a whole. So I hope that makes sense. All right. Is K-name like a string? So that's a good question. So K-names are literally just a type def for a U64. So what the heck is a K-name? A K-name is ultimately a hash of a string, right? So we pass a string to this K-name create, and then we use, internally we use a CRC64 hashing algorithm to take this string and convert it to a unique 64-bit integer. And we could have just used U64 everywhere, but I type def this as a K-name so we know specifically what it's used for. And so what this allows us to do is instead of passing strings all over the place and doing string comparisons all over the place, what we do is we create a k-name, and then anytime we have to do a string comparison, we're just dealing with k-names, which is just integers. So an integer comparison is lightning fast, right? Versus a string comparison. So this makes strings. We sort of have a way to sort of bake them within the engine, and then we sort of bake them down to a U64, which is just a 64-bit unsigned integer, right? And that is ultimately what we use for comparisons. So it's lightning fast, right? So I hope that makes sense. Bad Comic, how's it going? And then also, the other thing that happens is whenever we create a k-name, you might be saying, well, we've created this k-name, but what do we do if we want to get the original string? Well, part of what this does is it stores the original string in a global lookup table that we can then retrieve by using k-name string get and passing the k-name back. So if we actually needed the original string value, we can also retrieve that as well. It's not lost. Are k-handles random U64? So k-handles are a little bit different. So k-handles are actually two things. So it's a handle index, which is typically a index into a array of some sort of resource. So whenever we create a k-handle, we pass a handle index. So the best way that I could describe this is, let's say we have an array of textures, right? And that array of textures is like, let's say slot 0 is occupied by texture, slot 1 is empty, and slot 2 is occupied by texture. So when we load a new texture, we'll first see where in that array actually has loaded textures and where is free. We'll find a free slot. We'll say, okay, slot number 1 is free. Load up that texture. Flip the flag internally within the texture system for that particular one. Then the handle index becomes 1, right? So when we create a handle for it, we say the handle index is 1. And that gets mapped directly to this handle index. Then there's this second part, which is unique ID. This is a globally unique identifier. And what this is for is we generate this to go along with the handle index. Because typically the system generating the handle will also keep track of what this identifier is when we create the handle. The reason we do this is because this is uniquely created. It allows us to determine if that handle is actually stale or not. So let's say we got a handle to index 0, right? And then we got another handle to index 0. And then we released index 0. So index 0 is no longer like a loaded texture. It's no longer valid. And then we load a new texture, which says, hey, texture index 0 is now free. We can put it here. So what we have now is those two handles that were initially gotten still say, hey, we have a reference to handle index 0. But now we've loaded a new texture into that slot. But it'll have a different unique ID because it will have been regenerated. So when we go to actually retrieve that from the handle, we also do a comparison against the unique ID, and that will allow us to see whether or not we actually have a stale handle. If we do, we can then error or a warning about it, what have you. So yeah, that's basically what that's for. Does each system have a separate group of handles? So systems that use handles, yes. We're still converting systems to use handles. We're trying to get away from using pointers everywhere. We're trying to use handles instead because it's a little safer. So is it like string interning? Yeah, if you're talking about the k-name stuff, yeah, it's kind of like string interning. It's basically what it is. Yep. Gotta love using type defs like this. Yeah, exactly. Okay. Let's see. Yeah, you know what's hilarious, LaFoley? I think that is actually the blog post that originally got me thinking about this. I think. Yeah, that is the one. Yeah, so it's it helps us avoid null pointer issues or invalid pointer issues. Just by, it lets us handle that stuff gracefully. Do you have type states or an enumeration to describe the current state of an object. Depends on the object, right? So for our resources and assets, for resources, yes. Assets, no. So assets, when they load, a request is put out, an asynchronous request is put out. Thank you for the follow, by the way. An asynchronous request is put out with a callback that's passed in, saying, hey, whenever this asset is finished loading off disk or from wherever, call this back. And so typically a resource will say, hey, I need this asset, reach out to the asset system, say, hey, request this, and then it'll eventually come back. And whenever that comes back, then a flag will be flipped on the resource to say, hey, we've received the asset that comes in. So the asset's loaded, but we're not quite ready to use it, right? Because we have to upload it to the GPU or the sound card or whatever it is that we're doing. And so each one of those resources actually has a state, sort of like a mini state machine within it to say whether or not it's loaded and ready to use or whether it's in some other state. Async IO, controversial. I see no reason to hold that up, right? Because we can definitely be requesting multiple resources at once. Let's see, and then verify the state so you don't call a function the state isn't allowed to call, like an assert not invalid state. Yeah, or it's like, so in the event of, let's use materials, for example. Materials have references to texture resources. Those texture resources may not be loaded yet. They might be in the process of loading when you actually go to render something that's using that texture. So the way that the material system works is it checks to say, hey, is this thing loaded? If it's not, fall back to a default texture that we know for a fact is loaded and use that instead. So yeah, it's done by a callback as far as when that flag is actually flipped. Yeah. And then it's up to the system using it as to whether or not, that's operating through a callback or it checks it every time or whatnot. So it varies. It varies by system. It's not enforced by the resource or asset system. The callback flips a bit, or it calls a continuation. So, in the case of our, in the case of resources, right, that have gotten an asset back, depends on the resource itself and depends on the resource type, right? They each have different handlers for the different types because the requirements are different, right? So in some cases, it's a very quick, like, hey, we've got the resource or we've got the asset back. We can use that data directly. We don't have to do any GPU uploading or any of that stuff. And we can immediately just flip the flag. In some cases, we may not need to actually perform like a GPU upload, which again is asynchronous. So we may say, okay, well, now the asset's loaded, but we're not fully loaded, so we consider that a loading state. So we flip to the loading state, but then we might have a callback that's issued when the GPU upload is complete, and then it comes back and flips the flag to loaded. So it depends on what system is using it, what's checking it, where and how it's used, right? The asset system and the resource systems, for example, they don't enforce a pattern either way. Callbacks are optional and don't have to be used, but if you provide one, it will be called back. So it's totally up to the caller how to actually use it. I hope that makes sense. Okay. So I'm actually thinking, kind of thinking that maybe we shouldn't even do this, right? Maybe we should just do, so this is the static mesh system for that particular, this is the system for static meshes, right? So maybe we would also have things like static mesh create, right? With maybe some sort of data that gets passed to that. So be struct K-actor static mesh system state. There we go. And we would create this. We could do, well, let's think. When we create an actor component, we're always going to need to, I guess we might not always immediately attach it to an actor, or it could be moved to a different actor, I suppose. So we might want to think about that too. So whenever we create one, I guess what we would do is we would pass in a geometry and a k-resource material instance. And we would pass in a copy of those things, right? Because we don't want to have to be concerned with the life cycle of these things. So we pass in a copy of those, which is fine because a material instance is just kind of a single thing anyways. All it contains is a pointer to a material and a per draw ID, which wouldn't change for the instance. So that's fine. I still don't like K-actor static mesh create. I don't like this naming scheme yet. I'm not sold on it because this is a component that we're creating, right? It's a K-actor component, right? I mean, but I don't want to do that either because that's kind of terrible, right? That seems kind of terrible too, but less terrible, I guess. Maybe we abbreviate component. I'm not sold on it. Did it take trial and error or some years of experience to build this type of linear async IO system instead of just blocking? I mean, it's just, so we have a job system that we use internally to power all of that stuff. We haven't actually hooked that bit up yet. But we are using the job system for the old way of loading resources, which currently does work in a multi-threaded way. The old system is jobified, the new one isn't yet, but I know that it works because the old system works. So our job system internally spins up job threads and basically just sits there and waits for work, right, using semaphores. And then whenever it gets work assigned to it or a job gets dispatched to it, then it does the job and then makes a callback to say, hey, this job's complete, here's the data, here's the completion data of that job. So all of that stuff, all the multi-threaded aspects of it, and all of that stuff is actually offloaded to the job system and is completely abstracted away. I don't have to think about it. So whatever I use that for, typically does not have to consider that in any way, unless it's using some sort of static or shared data. But then I would argue, don't do that. But yeah, we don't block for that, right? We just we use the job system to handle it for us. We have threads that are already stood up, and those threads just use semaphores to keep from running in an infinite loop, more or less. Oh, you thought I said Javafied? No, Jobified. No, we're not doing Java around here. Bad comic, it has been a while since I've seen you. How have you been? Have you looked at the SDL3 GPU API? Been playing around with it recently. Seems fun. Briefly, I looked at it, yes, but nothing in detail. Reminds me a bit of Metal. What's the overhead of the job system? Minimal. I mean, I haven't, I guess, profiled it too much, right? But like, it definitely has made a difference in terms of loading things up quickly, multi-threaded wise. But yeah, I mean, overhead. So it utilizes semaphores, right? So that the threads that are open technically are in a loop, right? But those semaphores just sit there and wait until I actually trigger them, right? So while they're waiting, there's zero overhead. It's just a thread that's just sitting there waiting. So the only overhead there technically is the context switch between threads when you're actually, switching between what you're doing, right? So you have that context switch that happens there, which you can never get around, right? And then the overhead, I guess, of creating the thread. But other than that, it's minimal. There's really not much to it at all. There is the only other overhead I can think of actually is there are some memory copy operations that happen with the sort of result structure that gets passed out. There is a copy that happens on the way in and on the way out. But yeah, that's about it. There's really, I mean, it just sits there. It's using a semaphore, right? So like while it's sitting there, it's just not really doing anything. We do have thread pools also that are available to be used, but that's kind of a separate thing. So those basically will stand up threads and then do the work, and then join them and wait for all the threads to complete, and then kick off the complete callback that's passed. But again, there's not really any noticeable overhead with it. I mean, I could profile it, I suppose, but like, I doubt it's going to be anything crazy. I'm on Linux at the moment. Arch, by the way. I do support Windows. I'm just not on it at the moment. I'm on Arch Linux. Let's see. Even green threads will context switch when going from normal to green. Right. So yeah, I mean the job system has actually been in place. I forget. I added that early on actually, so it's actually been in place, and that code hasn't changed much since we initially wrote it. So it's pretty solid stuff. Okay, we should probably do. So let me think. When we create this, I wonder if we should do. I wonder if we should return the ID in this case. Right, because each one of these things is going to have an ID. I think that's prudent. Right, so that'll return an ID. And actually, now that I think about it, instead of doing these lookups like this, we should probably have a way to obtain the ID from a name / actor ID. And then use that ID to look up instead of these two things. And that would be a lot easier to use, I think. So it would be U64 return again, kactor component, static mesh, and then I guess get. I don't know if I want to get ID, I guess. So we have this. And then we have U64 actor ID and kname component name. I guess I could just say, I guess I could just say name. Right, and then this would just be U64 ID. Whoops, U64. Right, so U64 ID. That makes a lot more sense. Let me change this. Oops, actually I just need... Oh, why has it done that? Okay. Okay. That seems a lot better to me. So when we create it, we return the ID. We can also get it by ID. When we create it, we should also include U64 actor ID and kname name. And then those can be optional. Like if we don't want to use them, we could just pass 0 or invalid. And then we would also have void destroy, and that would just take the ID. I think that makes sense. X or Wayland. I am still on X11 using Cinnamon, actually. I want to use Wayland, but the problem is RenderDoc doesn't work on it right now. And so if I'm like in the middle of a debugging session, I don't want to have to switch desktop environments and whatnot. Just a pain. So I'm still on X. The reason I use Cinnamon is because it supports mixed DPI devices really well. So the screen we're looking at here is actually a 4K screen, but then off to the sides I just have 1080p screens. And handling the fractional scaling between those on a lot of windowing systems does not work well. But on Cinnamon it does. So that's what I'm using. H. Mendoza, how's it going? Good to see you. Let's see. I think I read that the API is inspired mostly by Metal and Vulkan. I haven't used enough of either to know myself. Yeah, when I was reading it, I mostly got Metal vibes from it. It's an abstraction around them plus DirectX 12, so it makes sense. Yeah. Is there any resources you'd recommend for learning multi-threading and job systems? Been meaning to look in that area. I mean, I hate to plug my own video. That's one resource, right? Because I did go through like all the stuff that we wrote it. Which we visited that twice. Because initially I didn't do it with a semaphore. Initially I did like a small wait. Which I later refactored to use semaphores. I can think of like talks and stuff that discuss how it works on a high level, but actual resources like with code examples, I can't think of any off the top of my head. I just kind of wrote it. Which I know is not a great answer. I will look and see if I can find one. But yeah, off the top of my head, I'm not sure. It's just something I kind of researched and wrote as I went. Really tired, gonna head off. Thanks for the stream. Awesome, Lawfully. Appreciate it. Have a good one. Appreciate you being here. Okay. So we have create, get ID, destroy. I guess this comp kind of makes sense, right? I think we can add that without making things too verbose. Okay. So I think this type of a pattern is going to be the way to go for each one of our systems. So this will be internal representation. It'll actually probably wind up looking like this internally. And then I guess we're really not going to wind up doing this. And I'm actually struggling to think of a reason that we're going to need this. The only thing that I can think that we might need this for is when we're parsing a file, we could essentially convert the string into this and then switch on the type when we go to actually create. But I don't even know if we actually need to do that. So I'm actually going to remove all of this for now, except this one, because that's sort of our reference point, right? To do internal, right? And I'm actually kind of wondering if this even needs to be, like, I almost kind of feel like the X form should be a component as well. And theoretically, the name could be a component, but I think I want to enforce having names. Juju, thank you for the Prime sub. I really appreciate the support. Thank you very much. Yeah, the support means a lot. I really appreciate it. Thank you. Okay. Let's see, what else are we going to need for the system? So I guess for the system state itself, or the actual system setup, we need a couple things. So we're going to have a B8 kactor comp system static mesh system initialize, right? I know that's kind of long, but it is what it is. So we're going to take a U64 pointer, and we're going to say memory requirement. And this is because we want our engine to actually own the memory that gets passed to the system. We don't want this system sort of creating its own memory on the fly if we can avoid it. So what we do is we pass a pointer to U64 to say, hey, system, we're going to set you up, but what is your memory requirement for that? And then we do a struct kactor static mesh system state pointer, and we'll say state, and then let's see, should we have configuration for this? I feel like I need to go ahead and set one up, so let's do that, even if it doesn't really contain anything. So we'll say typedef struct kactor static mesh system state, but instead of that, system config kactor static mesh system config. There we go. And I guess for here we'll just have a U64, U32 is fine. Max components, right? And so we'll pass through kactor static mesh system config, right? And so this will return true if the system is able to be configured and set up successfully, otherwise false. This will be it'll be the old double call. So the way that this is going to work is kind of like what we do a lot of times in Vulkan, where we call it once, passing a pointer to the memory requirement, or to hold the memory requirement, passing 0 to state, and then I guess we could just do a pointer here, and passing nothing to the config, and that will just fill out this memory requirement and then return true. And then we will allocate the memory needed for this guy, and then we will call it again, passing that allocated memory here and actually passing the config, and then perform the actual initialization, and that should get us where we need to be. And then we need shutdown, and all that's going to need is the state, and that's it. And that's not even going to return a boolean. That's going to just be void, because if that fails to shut down, And we could bleat about it in the console a little bit. Complain, but that's about it. Let's see. Did you study comp science to get a professional game engine dev job? Nope, I did not. I actually have a degree in game art and design, and I taught myself programming. Although it's a little bit misleading because I've been programming a lot longer than that. I actually started writing code when I was about 7 on an MS-DOS machine with QBasic. Aging myself there, I know. But yeah, I never actually went to school for programming. By the time I did take one C++ class in that program, and I could have taught it. So yeah, I do have a degree, but not in computer science. And I don't use it. Repo. Okay, so I actually don't have an exclamation point repo, but what I'll do is I'll just drop a link over here in the chat for you. And that's where the repo is at. I'll add, let me make a note, and I'll add a repo command, because I've seen that pop up a couple times, so I'll add that before the next stream. Thank you for the follow. Started studying computer science. I think this series is incredible. I recently started watching it from the beginning. Awesome. I'm glad you're liking it so far. And welcome. I hope you find it helpful and useful. Okay. So this is for the system itself. And then this is to actually use the system. So I think all of our systems are roughly going to follow this pattern, right? Where we'll have an initialize for the system, the component system, and a shutdown for the component system. And then the system itself will just have whatever functions it needs to operate the way that it needs to. And I think what we're also going to do is we're going to say that the actor component system is not actually going to worry about the loading of any resources or any of that stuff. I think by the time we get to this point, we should already at least have a resource stood up, and or a geometry or something to be able to reference here. We may or may not change our stance on that. We'll have to see. All right, so I guess let's take this over and actually start solidifying this in some implementation code. So do we have let's see, where was the let's unify our bar there real quick. All right, so this is in runtime world. Okay, so I thought that's where it was. I just couldn't. So we go source world. Okay, actor types. So I think the way I'm going to do this is I'm going to initially put this all in one source file, and I'll split it up later. Just while we're kind of figuring out what the API is going to look like, so I don't have 1,000 files, split with all this stuff here. So kactor, let's just call this kactor C. And let's actually rename this to just kactor H. All right. So we're going to convert all of these. First, we need to include kactor H, and then we're going to see if I can get that to repeat. Nope. Was it that? Oh, I can't remember how to do it. I'll just do it the hard way. I need to look up the, I suppose I could create a Vim macro to do this quicker, but it's only a few of them, so I'm not going to worry about it. Okay. So the way that all of these system initialization things work is, first off, I need assertions. I think that was under debug assertions. K-assert, yeah. So K-assert message, we need memory requirement. So if that's not there, then we need to scream at the user. So K-actor comp static mesh system initialize requires a valid pointer to memory requirement. Okay, so now what we're going to do is we'll set, actually before we can even determine that, we need to set up our internal structure, right? So this is the guy that we said we were going to use internally. So we're going to declare this in our C file, because this is going to be private to sort of this system, right? So let's get rid of this too. All right, so instead of like a hard-coded array like this, what we're going to do is we are going to create arrays, right? Like that. And we are going to calculate the memory requirement. So we're going to say, we're going to dereference memory requirement. And we'll say that's equal to, we're going to say size of, we'll do geometry, and we're going to multiply that by config max components. And then we're going to add to that size of k resource material instance times config max components, right? And so it's going to be that, and then all of that is going to be added to size of k-actor static mesh components, which I'm going to rename that here in a second. Okay. And then, so what that's basically going to do is it's going to allocate enough memory to hold this structure, and then create this array and this array, and then we'll assign those things. So we're basically going to have one big block of contiguous memory, and then we're basically just going to set this up to use that. So the next step of this is to say, hey, if we don't have a state, then all we're doing is retrieving the memory requirement. So we can just return true at this point. Because it's not a failure, we did what we set out to do in this case. Otherwise, we do have a state, and we just need to set it up, right? So we could say state, let's see, do we have, oh, you know what, I need to rename this, that's right. This needs to be static mesh instead of components system state. Same for here. All right, and here. Okay, so state and then materials. And the way we're going to do this is we're basically going to take this massive block of memory and we're just going to offset into this, right? So actually what we should probably do here is change this. Instead of taking in that structure, right, we're just going to pass in a void pointer there. Because I've actually run into issues with this before. So we're just expecting a contiguous block of memory here, that's it, right? So the way we're going to say this is state materials. And we're going to actually, let's do Let's call this state block, right? And if not state block, and then here we'll do kactor static mesh system state equals, and we'll cold cast state block to that, right? Then we can say state materials equals state block, right, which is going to be the address of state block. And then we're going to move that forward by the size of kactor static mesh system state, right? So basically what we're saying is the struct itself, right, which includes the pointer to geometry and the pointer to materials, right? So this, essentially, block, is the first bit of that memory that we're going to use. And then after that, we're going to say state geometries equals state materials. And we're going to cast this to, we should probably cast this to like a U8 pointer, actually, to be safe. So we're going to cast that to a U8 pointer. Basically, that's going to give us the address where this materials array begins. And we're going to move that forward by, let's see, we should probably size of geometry times config max components, right? And so what that's going to say is basically within the block of memory, state is going to be the first part of it. The materials array is going to be the next part of that memory after the actual structure itself. And then the state geometries is going to be after the materials array itself, right? Which I realized I've got those backwards. It should be geometries first, then materials. So this should be, wait a minute. This should be geometries, and this should be materials, and this should be geometries. There we go. Had that backwards for a second. So geometries is going to be the next block of memory, and then materials will be the block of memory after that. So we do all of this to get the address, right? And then we need to take that address and cast it back to k-resource material instance pointer, right? And once we've done that, we're done. So in this case, there's nothing here that could cause us to fail that as long as we have what we need here. All right, let's see. Does anybody use the college degree they got? I don't think I know a single person who does. Yeah, I know a lot of people that don't as well, for sure. Trying to graduate, but they always tell me it's useless. Yeah, I mean, yeah, I haven't wound up using it. But your mileage may vary, right? So I'm never going to say, you won't ever use it, right? It varies. Code Void, how's it going? Good to see you. Necks and Tires, welcome, by the way. The distro I'm using is Arch. I could add an exclamation point distro too. Haven't been asked for mine in a single place I have worked. Yeah, that's fair. Arch mentioned. Yeah, Arch, by the way. Yeah, see, it even says Arch down here. The repo command worked? Did it? Oh, it did work. I forgot I added it then. It didn't, because what happened was I saw the repo, but like the Streamlabs chat didn't pop up immediately for me, so I assumed it didn't work. That's funny. Okay. Use Emacs. I tried Emacs and I didn't really like it. Maybe it's because I've been using NeoVim for so long, or just Vim in general. But yeah, I got so used to the Vim way of doing things that I think I would rather write my own text editor than switch to Emacs. Yeah. But I always say use whatever you're familiar with, right? In my case, it's Vim. Um, Although I debug with a different editor, whose name I won't say, but yeah, to each their own, right? Um, all right, so our shutdown is if state. All right, and then to do things and stuff. Because we don't have anything to shut down right now. We don't have any resources to release or anything like that. So that may change once we actually start processing these things. I might go through and release these material instances. I'm not 100% sure. What window manager? I use Cinnamon at the moment because it supports mixed DPI display devices really well. It's one of the few that actually handles it properly. So I've stuck with it for quite a while now because of that. Yeah. Because if you know anything about X11, mixed DPI on X11 is a nightmare. And Cinnamon seems to be the only one that really handles it correctly on X. So yes, I could use Wayland, but RenderDoc doesn't work on Wayland, so I can't do it. Okay. Well, so I was kind of hoping to get into this portion of it tonight, but we kind of got caught up in chat, which is fine. I'll likely have some more work done on this next time we stream. So, speaking of that, so I do have to get up and go to work in the morning, so I can't stream anymore tonight, but I might wind up doing a makeup stream tomorrow night, only because I missed last night. So what I will do is, if you guys are able to, I will announce on Twitter, the YouTube channel, and the Discord server if I am able to go ahead and stream tomorrow. I'll announce it on there when I do. I just don't know if I'm going to be able to or not. So stay tuned for that. If you haven't already, I would really appreciate a follow, either on the YouTube side or the Twitch side. Both help me out immensely because I'm hoping to motivate more people to get out there and write game engines. That's kind of the purpose of this, is to motivate people to do it so we have more competition, because I think that's a good thing. So thank you very much for the follow. Thank you guys for all the support tonight. I really, really appreciate it. It means a lot to me. And we're going to choose somebody to raid real fast. I just want to see. I want to see if there's somebody that's kind of doing something a little bit similar to what we're doing. And if there's not, I see that there's a few options in here. So let me see. Just going to find somebody to raid. Give me a moment just to sort of scroll through the list here. I should probably do filter by category. Let's see. Actually, it doesn't look like there's too much in the world of like C programming. Yeah, it doesn't look like there's much in the way of C programming tonight. Oh, wait a minute. Soulfoam is online. We're going to raid Soulfoam. Perfect. All right. He's raided me before, so I'm going to return the favor. So, anyways, thank you guys so much for hanging out with me. I greatly appreciate it. And I will see you guys on the next stream. Have a good one. See ya.